Alright, so in this problem, I have 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So my equation is 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. Now, to solve this, what I'm going to do is first factor out 2 to the power of 10 from my left-hand side. So if I factor out 2 to the power of 10, I get 2 to the power of 10 times, well, 2 to the power of 10 divided by 2 to the power of 10 is 1, so I get 2 to the power of 10 times 1 plus 1 is equal to 2 to the power of x. Now from here, 1 plus 1 is equal to 2, so I get 2 to the power of 10 times 2 is equal to 2 to the power of x. And a simpler way of doing this is, instead of just factoring this out, well, we have two 2 to the power of 10s here, and if anything added by itself is the same thing as that number times 2. So we could have just said 2 to the power of 10 times 2 at the beginning instead of factoring it out. So now from here, what I want to do is I can actually do this, solve this from here in two methods. So for method 1, I have 2 to the power of 10 times 2 is equal to 2 to the power of x. What I'm going to do is I'm going to rewrite 2 as 2 to the power of 1. And now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, 2 to the power of 10 times 2 to the power of 1 is equal to 2 to the power of 10 plus 1, which is equal to 2 to the power of 11. So I get 2 to the power of 11 is equal to 2 to the power of x. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to 11. Now, method 2 of solving the problem from this step right here. So I have 2 to the power of 10 times 2 is equal to 2 to the power of x. Now, instead of multiplying 2, I'm going to divide 2 on both sides. So then these two cancel out, and I get 2 to the power of 10 is equal to 2 to the power of x over 2. Now 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 2 to the power of 1, that's going to equal 2 to the power of x minus 1. And now, again, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 10 is equal to x minus 1, or I could write this as x minus 1 is equal to 10. And now if I add 1 on both sides, these two cancel out, and I get x is equal to 10 plus 1, which is 11. So as you can see, these are the two methods, and method 1 is actually much simpler. It only took a couple of steps compared to method 2. And now the final step that we have to do, and we always have to do this in every equation, is to check our answer. So our equation was 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. We got x equals 11, so I get 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of 11. 2 to the power of 10 plus 2 to the power of 10 is the same thing as 2 times 2 to the power of 10. And 2 to the power of 1 times 2 to the power of 10 is the same thing as 2 to the power of 1 plus 10, which is equal to 2 to the power of 11. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a is which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.